today we're going to be solving in the next playlist this set of questions for no particular reason at all. Let's get to it. Okay, so we are told to consider the MOSFET amplifier in the figure 7.10 for the case, and then I'm given all of the numbers that I could need. But in any case, I'm solving this amplifier. I see that, this is the drain, this is the gate, this is the source. The source is 0, so I can say this is common source, right? And so I kind of know what values to expect already based on the fact that this is a common source transistor, but let's try to actually do the math. So find ID. So my first thing is I'm going to assume saturation. Why? Because we always do this. It makes things easier. Half Kn VOV squared is always equal to 1/2. What is Kn? I'm told that Kn is 10 milliamps. And VOV squared is nothing but VGS minus VT, because VOV is equal to VGS minus VT. We all know this by now, right? Which is equal to, so 5 milliamps multiplied by, what is VGS? Well, VGS is equal to 0.6. What is VT? 0.4 squared. This becomes 0.2 squared, which becomes 0.04 times 5, which gives me 0.2 milliamps is my ID. Now, what is VDS, right? Well, VDS, if I was to look here, I understand that VDS is nothing but VDD minus ID or D. Why? I mean, this is the voltage drop that happens. Okay, so the voltage drop that happens across a resistor is nothing but the current times that resistor. So V is equal to IR. This is the voltage drop that happens across the resistor. So I'm saying voltage minus voltage dropped is equal to new voltage, right? So VDD minus IDRD, the voltage dropped here, is equal to my new voltage, VDS. Which makes sense, right? Intuitively, this makes sense. So it's equal to VDD minus RD. VDD minus RD or D is my VDS. And what is VDD? We are given 1.8 volts. And what is ID? I just found 0.2 times 10 to the negative 3. And what is RD? 6.8 times 10 to the 3. So this cancels this. And I have 1.8 minus 13.6. No, sorry. 1.36. And so that should give me 0.44 volts. Unless I did something wrong, which I might have. But let's continue. So that's part A. Done. Part B. Calculate the value of GM at the bias point. Well, GM is equal to Kn VOV. Why? It just is. There's a lot of complicated physics behind this, and I'm not intelligent enough to explain that to you. So GM is equal to Kn VOV is a formula. We all memorize this, okay? So what is the value of the GM at the bias point? Well, I can just ignore the second part because I don't even know what it means. But it's just VGS minus VT because I know that this is my formula. And Kn, I am told what Kn is. I am told that Kn is going to be 10 milliamps or 10 times 10 to the negative 3. And VGS, I am told, is 0.6. And VT, I am told, is 0.4, which gives me 10 times 0.2, which gives me, what, 2 times 10 to the negative 3. Right, so that's my GM. And should be correct. C. Calculate the value of the voltage gain. What is AV equal to? Okay, now this is the complicated part. I can proceed by using either the pi model or the T model. Every time you see the word gain, you have to transform it to either the pi model or the T model. You have to, right? So I'm just gonna choose the pi model because I like pi. But you could do the T model too. It's up to you. So the pi model, the way that you remember it is GST, right? If you live in Ontario, the tax in Ontario is GST. This is nothing but GSD, right? Tax, because this course is very taxing. So tax, GSD, and I always put a current source here, which is nothing but GM VGS. Why? Because it's the transconductance times the voltage between the gate and the source is the current that flows through the transistor. But really, we don't need to know any of that, so just take it as a rule, right? The current is GM VGS, memorize, okay? And now I fill in the blanks. So if I have VGS, and I know that this was connected to my sort of ASIC, and then this was my, whatever, right? And then this is always an open circuit. S was 0, so S connected to the ground. I'm just literally copying over things from here. Here, I'm looking at this, I'm analyzing, I'm seeing what can I do. And D is connected to RD, and I have VDD. So, the one thing you have to keep in mind is to turn off DC in all transformations. Every single time you transform something, you have to turn off DC. You just have to, right? Now that I've told you this, I'm asking you for the gain. What is AV? So first step is do the pi model or the T model, and we just finished that, right? You can see that this is equal to, these are equivalent circuits. GM I found here, and VGS, I know what VG is, just VG minus VS, which is literally equal to VG, right? So this can be VG. Why? Because VGS means VG minus VS, and VS is 0, so it's GM VG, right? And GM is given to me. Now my step 2 is to find the gain. AV is equal to DVO by DVI, which is what? What is my voltage output in this case? Here, I see that my voltage input is VGS, and my voltage output is VDS. So I'm saying it's going to be dVDS by dVGS, which is what? VDS, what is VDS equal to? It's nothing but the current, right? You agree that this is VD. And to find VD, it's nothing but I times RD, which is equal to minus GM VGS, because right now, I need to make this neater. Right now, the current flows like this. But I want the current flowing like this, positive, negative, because VD, right, with respect to ground, I want this to be my VD. So it means that I'm flipping the direction of my current from down to up. So minus GM VGS times RD is my VDS. And so if I was to take the derivative of this with respect to the input, which is dVGS, then it's just minus GM RD. Do I know what GM is? Yes, I do. GM is nothing but 2 times 10 to the negative 3. I found this above. So minus 2 times 10 to the negative 3. What is RD? Well, RD is nothing but the resistance that's been given to me, 6.8 kilo ohms. So times 6.8 times 10 to the 3. Cancel the things, and then we get 6.8 times 10 times negative 2, which is minus 13.6. I think I made an arithmetic error. No, I'm good. Okay, so we're done with this part. Let us continue. D. If the MOSFET has lambda equals to 0.2, find R naught. Okay, R naught is equal to VA over I, or 1 over lambda times I. That is to say that VA is equal to 1 over lambda. This is just memorize, unless you're a physicist, at which point you should not be watching my videos anyways. But basically, that's just memorizing. VA is equal to 1 over lambda. R naught is equal to 1 over lambda I, which is equal to VA over I. And this is just, you memorize and don't question me. Okay. So basically I'm just saying 1 over lambda I, right? And that becomes nothing but equal to 1 over lambda, which is nothing but 0.2 times Kn VOV squared. Again, I'm assuming saturation. I have already found this above when I told you that ID is equal to 0.2 milliamps. Right, so it's going to be 0.2 times, 1 over 0.2 times 0.2 milliamps. And we found this above, right? We said that 0.2 milliamps here, so just, rewind if you want to watch that again. And that's equal to 1 over 0.04 times 10 to the negative 3. So this I can move up to get kilos. So R naught is equal to 1 over 0.04 kilo ohms, which is equal to 25 kilo ohms. And that is question 7.25. I will see you in the next video. Ali here. I just realized that I've missed one important part of the question, which is asking me to find the new voltage gain, right? So I thought I'd already found the voltage gain, which I did. But now they're asking me to find the new voltage gain in this model, given that lambda, or that R naught, is equal to 25 kilo ohms, right? So I told you that R naught is equal to 1 over lambda I. But where does R naught fit in this model? So to understand this, I'm going to need to draw the pi model again, which should not take us that much time now that we're professionals at it, right? So we understand that it's going to be tax because this course is taxing. GSD. We always have GM VDS, and it's always flowing from drain to source because this is the NMOS transistors, and the gate has the AC signal and nothing else. This is an open circuit. The drain, gate, source. The source is connected to ground, and my VDD, so it's RD. And always turn off any DC sources when you're doing the pi model. So this becomes ground. Always turn that off, right? Now, I have this resistance R naught is equal to 25 kilo ohms. Where does this go? Rule. Always. R naught is between D and S. This is always true. D and S. So it will always be in parallel between D and S. And this is your R naught, which is equal to 25 kilo ohms. Now, given this new value, you're asking to find AV, right? That's what the question is asking. Find the voltage gain. AV is equal to VO by VI. I understand that the voltage in the input is VG, and the voltage in the output is VD. Well, technically VGS and VDS, but S is 0, so I just ignore that. So I'm saying dVD by dVG. Well, so now I just have to find what is VD, right? What is the voltage in D? In the past one, it was simple because I could just do current times resistance. Here I can't really do that, so I'm going to elect to do nodal, and I will do nodal at node D, which means that, or, you know what? No. Here, I understand that this is connected to ground. So R naught is between D and 0, and RD is between D and 0, meaning that I could technically redraw this in this format. And technically I could, connect these two together because it's ground, which means that I could say that this is in parallel, no? So there's RP, right? Which means that I could simplify this part of the circuit. GMVGS. RP. Which means that VD is equal to GM VGS RP, D by dVG, S is 0, so it's equal to minus GM RP, where RP is equal to RD times R naught over RD plus R naught. RD is given to me in the question. R naught I have found to be 25 kilo ohms, and RD is 6.8 kilo ohms, so minus GM, and GM I have found in port B to be 2 times 10 to the negative 3, so I do minus GM times RD times R naught over RD plus R naught. Sub in my values, and my final answer should be minus 10.692. So that's the continuation, and that's the final part of the question. And Baba here, let's proceed. So 7.23, the problem investigates the nonlinear distortion introduced by a MOSFET amplifier. Let the signal VGS be a sine wave with amplitude VGS, and substitute VGS equals VGS sine omega t. How many VGS did I say? What am I saying? I'm saying VGS is equal to VGS sine omega t. That's all this portion is said. And they're giving us sine squared theta is equal to 1/2 1 minus cos 2 theta, which is, a given formula, right? Everyone knows this one. Show that the ratio of the blah 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 blah. Okay, so I will do this later. But I understand from the get-go is that ID is equal to 1/2 kn vg v of v squared. Here, I have VGS and I have normal VGS. Right, so I'm told that I have this is kind of like if we were to think back to a normal MOSFET, I'm told that I kind of have this kind of thing, right? I have two of them. So it's no longer just VGS minus VT. No, this is wrong, right? Rather, it's going to be half Kn VGS plus VGS, right? Minus VT squared. Okay, before I substitute my values, I'm just going to expand this because that's just the way to solve this question. You have to expand, okay? And it makes things easier. Now, what is the expansion? Usually for me, to memorize this, it's easier to just say half Kn times something squared plus 2 times half Kn times something else plus half Kn times something squared. I don't know why, but this pattern just feels familiar to me. Maybe you can memorize it in some other way. If you expand this the normal way, you'll still get the same answer, but this is just a shortcut. Basically here I'm going to say it's going to be VGS minus VT plus VGS minus VT, not squared, times little VGS plus half Kn little VGS squared. So notice the pattern is this whole thing squared times this thing. So 2. So I guess if I was to give you a pattern for this, right? If I wanted to give you a pattern for it, I guess I could tell you, let me just clean this up a little bit. VGS minus VT to the 0 to the 1 to the 0. Right, so notice, and this would be VGS to the 0. So notice how we say half Kn VGS minus VT squared, and then it goes to the second term VGS minus VT to the 1, and then it's VGS minus VT to the 0, right? And here's VGS to the 0, and here's VGS to the 1, and here's VGS to the 2, right? So in that way, it's kind of, there's some similarity, so it's easier to memorize. And here I can ignore this term and, clean up because to the 0 is just 1. And this is the formula that I end up with. Now, it's very simple to proceed, and we proceed by substituting my VGS equals my capital VGS sine omega t, which was given to me in the problem. So it's equal to half Kn VGS minus VT squared plus Kn VGS minus VT times little VGS, which is nothing but VGS sine omega t. So notice that this and this are equal, plus half Kn VGS squared sine squared omega t. And again, notice that a different color this time. So this term and this term are equal. And what is the question asking me? The question is asking me to show that the ratio of the signal expressed in 2 omega, expressed in omega. Right now, I have nothing. I have omega t, and I have omega t. So maybe it's time to use that transform, where sine squared theta is equal to 1/2 1 minus cos 2 theta. So I'm going to say half k, and I do nothing with this one, VGS minus VT squared, plus, I'm too lazy to write all this out, so I'm just gonna, Kn VGS minus VT plus VGS sine omega t, plus 1/2 Kn VGS squared, and sine squared is nothing but 1/2 1 minus cos 2 omega, or 2 theta, right, which is 2 omega t, right? Which comes down to be If I was to further simplify this, we would have it equal to, well, okay, all of this, and then I could expand this. Half kn VGS squared times half minus half kn VGS squared cos 2 omega t. Now, show that the ratio of the signal at frequency 2 omega to that at frequency omega is equal to this thing. So, why is it doing that? Okay. The frequency at 2 omega is nothing but this magnitude. The frequency at omega is nothing but this magnitude. So if it's asking me for 2 omega to omega, so if it's asking me for this, right, or at least the magnitude, so therefore the magnitude at 2 omega is minus 1/2. Whoa, I missed something. It's half kn VGS squared minus times another half, right? Because it's 1, 2, 3, 4 terms times minus cos 2 omega t, right? So it's going to be minus 1/2 times 1/2 times kn times VGS square over kn VGS minus VT times VGS, right, sine omega t. And then I guess I could cancel this with this, and this with that, and I'd end up with minus 1/4 times VGS over VGS minus VT. Whoa, and that's nothing but VOV, right? But they asked us for the ratio, and so usually if I'm trying to find it as a percentage, I take the absolute value. Why I take the absolute value is just something that is done. It's just the ratio of the magnitudes, right? Remember we said the magnitudes, which means that I don't really worry about this negative sign. So I end up with 1/4 VGS over VOV. And that's exactly what they wanted me to find. Notice that the question was asking me to demonstrate this. And we notice that this is the same, it's the exact same thing, right? Because that's how it is expressed as a percentage. So we're done, are we? In a particular application, VGS is 10 millivolts. Find the minimum overdrive voltage at which the transistor should be operated so that the second harmonic distortion is kept to less than 1%. Okay, so if I understand that at a percentage, it's 1/4. So VGS over VOV times 100 is equal to 1%. Then 1/4, basically VGS over VOV is equal to 0.04, right? 0.01 times 4 is 0.04. And VGS is 10 millivolts, so I'm given that this is 10 times 10 to the negative 3, which means that I can multiply both sides by 10 to the 3, such that I have 10 over VOV is equal to 40, and such that VOV is equal to 40 over 10, such that VOV is equal to, whoa, I made a mistake. VOV is equal to 10 over 40, which is equal to 1/4, which is equal to 0.25. And that's it for this question. I will see you guys in the next back. So I take it you've already read the question. If you haven't, take a minute, pause, read the question. In any case, first part, I'm just verifying, right? Let's verify. So what is verifying? Step 1, assume something, anything. I have two equations. Saturation, I will assume saturation because it's easier. ID is equal to half kn VOV squared. You tell me that ID is equal to 0.5 times 10 to the negative 3, and half, and you tell me that Kn is equal to 4 milliamps, so 4 times VOV squared, which implies that VOV must be equal to, so this is 1 times 10 to the negative 3 over 4 times everything, so it's going to be 1 over 4 squared. So VOV is equal to 1 over 2. This must hold true. Is this true? Now you're asking me to verify, right? Verify that they're true. So VOV is equal to VGS minus VT, meaning that VGS minus VT must be equal to 1/2 for this to be true, right? No? And VT is 1 volt, given, such that VGS is equal to 1/2 plus 1, implying that it's equal to 3 over 2, or 1.5. So VGS must be equal to 1.5 volts for this to be true. And is this true? This is indeed true. So I have verified that Mr. Adol Sedra is correct. B. Find GM and or not. And GM is nothing but Kn VOV. And Kn, I am told, is 4. And VOV, I am given, is half times 10 to the negative 3, because 4 milliamps. Implying that only 2 times 10 to the negative 3. And or not is nothing but VA over ID, and that's just your formula, or 1 over lambda ID. It does not matter because VA is equal to 1 over lambda. This is nothing but formulas that you have to memorize. VA over ID is 100. ID is, what is ID? 0.5 milliamps, implying that it's going to be 200 kilo ohms. Part C. Draw a complete small signal apologies. Anyways, C is draw a complete small signal equivalent circuit for the amplifier. So I'm drawing a small signal equivalent for that circuit over here. Can I fit it in one page? You know what? Sure, yeah, I can. So to draw the small signal, I've already shown you how to draw the pi model. I think it's time you get some T model practice, right? Because, you know, what can I say? I'm just so amazing. I'm giving you guys all sorts of practice. Anyways, I'm sorry, this is painful, but anyways, we have the gate, the drain, the source, right? So what does the T model tell me? T model tells me I'm to draw the drain, I'm to draw the gate, and I'm to draw the source. Between the gate and the source is some resistor, which has the value of 1 over GM, which is equal to RM. And between the drain and the gate is nothing but a GM VGS. I'm done with my T model. Now I'm just filling in the blanks. The first thing that you have to understand is that there are no DC sources in the small signal model. You have to know this by now. There are no DC sources in the small signal model. Right, so this is 0 and this is 0. And step 2, capacitors are short circuits in the small signal model. Now, I can from the get-go say that, let's look at this part here. If I have a resistor and I have something that's short circuit, then this resistor doesn't count, right? So this is just a short circuit. So I can do this. And the drain. The drain has 2 resistors. So this is D. And they are both connected to the ground, no? So I could kind of continue this and I can tell you that this is 2 resistors in parallel, both of which have a value of 16 and 16, implying that the final resistor is going to be 8, right? Just when they're both the same, you just half. Or you can just, if you don't trust me, just do 16 times 16 over 16 plus 16, and you're going to get 8, right? But why don't you trust me, bro? My feelings are hurt. Anyways, drain, 8 kilo ohms, and, right? Okay. And source, and I'm done. So I'm done with this half of the circuit. And I'm now doing the second half of the circuit. I'm looking here. The gate connects to, again, gate is connected to 110 mega ohm resistor, connected to ground, and another 5 mega ohm resistor, connected also to ground, such that they're both in parallel, and 10 times 5 over 10 plus 5, and that should give me 10 over 3 mega ohms. Why? Because math. So I can just say, as this resistor is nothing but 10 over 3 mega ohms. which connects to V sig, which connects to ground. I'm done with part C, right? Now, let's continue to part D, which is find Rn VGS over V sig, VO over V sig, and VO over V sig. Sorry, this is VD, and this is VO. Okay, let's start with VGS over V sig, because it seems to be the easiest. VGS over V sig. Vs equals 0. Vg. To find Vg, let me do nodal at this point. So I'm saying that the current flowing in this direction plus the current flowing in this direction plus the current flowing in this direction is equal to the current entering, right? Meaning that I'm saying that Vg minus V sig over R sig plus Vg minus 0 over 10 over 3 mega ohms. Tera, giga, mega is 10 to the 6. So this is times 10 to the negative 6, which is, anyways. Plus Vg minus 0, because S is 0, over 1 over Gm. So 1 over Gm is equal to Gm Vg, because S is 0, right? So VGS is nothing but Vg minus Vs, which is equal to VGS, which is equal to Vg. So I subtract Gm Vg from both sides, and I get Vg minus V sig over 200 times 10 to the 3 plus 3 Vg over 10 times 10 to the negative 6 is equal to 0. I can multiply, 10 to the 6. I can multiply both sides by 10 to the 3. Can multiply both sides by 10. I can multiply both sides by another 10. This is very slow. I need to use a calculator. Okay. And then I can multiply both sides by 2, I suppose. So Vg minus V sig plus 6 Vg over 10 squared is equal to 0, such that Vg plus Vg over 10 squared, so this is 10 squared, so this is 100 Vg, so this is 106 Vg over 100 is equal to V sig, which means that Vg over V sig is equal to 100 over 106, which is to say, whatever number that is, bro. I'm not gonna simplify, like 50 over 50, 50 over 53. Sure, okay? So it's gonna be about like 0.95 or something, I don't know, right? So that's part 1, Vg over V sig. What about VO over VGS? So let's just do a line here. What about VO over VGS? So I have done this part. I'm now doing this part. VO over VGS is equal to what? What is V output here? Where is the original circuit? Copy. Paste. What is the voltage output in the circuit that should give me VO over VGS, right? So in this case, I know that this is VGS and my VO is right here, right? It's that voltage at the output between positive and negative 16 kilo ohms, which I have simplified in my model to be 8 kilo ohms. It's easy to say, okay, but how can I say this is right? Can I not move this side of the 16 kilo ohms since it's connected to the ground, remember, because this does not exist? So is it not, if this is V, and this does not exist either. So I suppose an easy way for me to do this is if I was able to just kind of, right? And I was able to do this. And I was able to take this resistor, 16 kilo ohms, and I was able to put it here. 16 kilo ohms. Is this not equivalent? Right? So the voltage across this and this is nothing but V out, which implies that V out is equal to the voltage across the 8 kilo ohm resistor, and I just have to find the voltage here. And so what is the voltage in this case, given the output? I could say 8 kilo ohms is my V output, right? And I'm just redrawing the exact same thing in a simpler way for me to solve. And if that is the case, then V output is equal to the current flowing in this, direction, making a positive and negative, and that's my V output. So V is equal to IR, implying my V output is equal to my current, I, times my resistance, 8 kilo ohms. And my current is GMVGS. However, note that GMVGS flows in this direction. I don't want that. I want the current flowing in this direction. So I need to reverse the polarity in order to reverse the direction. So I do minus this times 8 kilo ohms, and I end up with, what is GMVGS? I swear, yeah, GMVGS. Well, GM is 2 times 10 to the negative 3. And VGS is VG minus VS, and VS is 0, so I get rid of that, times 8 kilo ohms, which is 8 times 10 to the 3. So I get 10 to the negative 3, so it's equal to minus 2 times VG times 8 is equal to VO. I'm trying to find VO by VGS. You know what? Might as well keep the S there. VO over VGS is equal to minus 16. And that's perfect. Now the last part is VD. No, actually, sorry. It's VO by V sig. Now, can I say VO over VGS times VGS by V sig? I need to improve my handwriting. What is this chicken scratch? VGS by V sig times VO by VGS equals VO over V sig. I could absolutely say this, no? So with the understanding that VG by V sig times VG times VO by VG is equal to VG, no, is equal to VO by V sig, given that they cancel out. And with the understanding that VG by V sig is equal to 50 over 53 times V over VGS is equal to minus 16, I cannot say that VO over V sig is going to equal to, well, 50 over 53 is nothing but 50 over 53. I feel like I've made a mistake. No, I haven't made a mistake somewhere. VG over V sig. Okay, I suppose I could leave it at this. So VO over V sig is equal to minus 16 times 50 all over 53, which is something like 15 point something, right? Should be about that because it's going to be like 16 times like 0.9 or something like that, right? So it should be about like 15 point something. And yeah, you find the math, you do the math, and it should be correct. I think this is it for this question 7.33, and I'm out. Okay, so this one is a little bit long, however, it's very rewarding to do, so let's get to it. Find the values of RS, RD, and RG so that ID is equal to 0.4 milliamps. Now, as usual, before I even begin, I write down my equation. ID is equal to half Kn VOV squared. I understand that you want ID to be 0.4 times 10 to the negative 3. Half, you tell me that Kn is 5 times 10 to the negative 3. And VOV squared. I also know that VOV is equal to VGS minus VT. Is that good for you guys? Like, do you guys want me to... Anyways, VOV is equal to VGS minus VT. And VT is 0.8, so that's equal to VGS minus 0.8 is equal to VOV. Now, in any case, when I do the math for this equation, I end up with VOV is equal to 2 times 0.4 times 10 to the negative 3 over 5 times 10 to the negative 3. I cancel this with this. I get 2/5 or 4/10 of 0.4, which is about 1.6 or something. Anyway, is equal to VOV squared, and so square root that 1.6 square root is 0.4. So that's VOV. Now I can do this into my equation. 0.4 is equal to VGS minus 0.8, implying that VGS is equal to 1.2, and that kind of stops there. Now, the largest possible value for RD is used while a maximum signal swing at the drain of 0.8 volts is possible. So it's a lot of maximums. And to me, the minute I see the word maximum, I say, oh, okay, ID is at that sweet spot where saturation and triode meet. What is the condition for saturation and triode? The condition is that VDS be greater than VOV. But since I'm seeing the word maximum in a lot of optimizations, I'm going to say VDS is equal to VOV. Is this correct? No, because you tell me that there is a maximum signal swing at the drain of 0.8 volts, meaning that the drain can swing positive or negative 0.8, and I should still be greater than VOV. So VOV plus 0.8. Why? Because VDS at its absolute lowest point is going to be VDS minus 0.8. And at its absolute lowest point, it should still be greater than or equal to VOV. This is allowed. VDS minus 0.8 with the swing of 0.8 is allowed, meaning that VDS should be greater than or equal to VOV plus 0.8, and therefore VDS is equal to VOV plus 0.8, right? What is VOV? Is 0.4, so VDS is equal to 1.2. I'm talking about these numbers here, right? So now I have, in summary, VOV is equal to 0.4, VGS is equal to 1.2, VDS is equal to 1.2. Now, you want me to find a bunch of numbers. The resistance at the gate is 10 mega ohms. Neglect the early effect. I have no clue what that even means, so we're just going to ignore it. And we have to neglect it anyway, so I'm just going to assume that no one wrote the sentence, right? Now, find the values of RS, RD, and RG. In this scenario, I'm just going to draw a normal sort of DC model. Implying what? Implying that this becomes open, so I ignore this. This is open, this is open. So I simply have RG, nothing but RS, RD. Agreed? We are in agreement, right? And we understand that this is my VS, this is my, VD, this is my VS, and this is my VG, right? So, where do we proceed from here? We want to know the values of RS, RD, and RG such that ID is equal to 0.4 milliamps. So, ID has to equal to 0.4 milliamps. So 5 minus VD over RD has to equal to 0.4 milliamps, right? Implying that, and VD, S equals 1.2 volts. VDS equals 1.2 volts. VGS equals 1.2 volts. VOV equals 0.4. What does this tell us? VDS is nothing but the voltage in between VD and VS, and that is 1.2. And VGS is nothing but the voltage between VG and VS, and that is 1.2 as well. We have to understand that VGS is equal to VG minus VS. You see here that VG is equal to 0, because no current flows, I is equal to 0. If no current flows, then this is 0 as well. For no current to flow, the voltage at this point and the voltage at this point have to be the same. No current flows because no current goes through the gate. We understand that. It's one of the principles of the transistors. Implying that VG is 0, so VGS is equal to minus VS. And VGS is equal to 1.2 is equal to negative VS, so VS is equal to minus 1.2 volts. Okay? So through some complex math, not even that complex, but really just saying that no current flows through the gate. For no current to flow through the gate is 0. If the gate is 0 and VGS is equal to 1.2, then VGS equals VG minus VS equals 1.2, and this is 0, then VS equals minus 1.2 volts. And continuing off this math, VDS is equal to VD minus VS, and VDS is equal to 1.2 is equal to VD minus VS. Minus VS is 1.2, so 1.2 is equal to VD minus 1.2 volts, which is just plus 1.2 volts. So VD is equal to 0. So this is also equal to 0, implying that 5 over RD is equal to 0.4 milliamps, which means that 5 over 0.4 kiloohms is equal to RD, implying that RD is equal to 5 over 0.4, which is nothing but 12.5 kiloohms. There I have RD. Solved. Now, what's the second part? The second part is, what is RG? Okay, and what is RS? Okay, can I find RS? Well, again, the same current, ID, is equal to VS minus 5 volts over RS, such that RS is equal to VS plus 5 volts divided by ID, which is 0.4 milliamps, which means that RS in kiloohms is equal to 5 minus 1.2 divided by 0.4. 5 minus 1.2 is 3.8, and 3.8 divided by 0.4 should be about 4, 8, 12, 16, 20, 24, 28, 32, 36, about 4 point, about 9.5, yes, 9.5 kiloohms. So KRS is equal to 9.5 kiloohms, and we are done with RS, and we are done with RD. So what is left? What is left is to find, well, I'm told RG, the resistance at the gate, is 10 megohms. So do I really have to do anything? The input resistance at the gate, RG, is equal to 10 megohms. So this is like what do they want me to do? They already gave me the answer, right? RG is equal to 10 megohms. Find the values of GM and R0 at the bias point. Let me just do this really quickly so that I don't have to keep scrolling up and down because, just not elegant. So find the values of GM and R0 at the bias point. Well, GM is nothing but Kn times VOV, and VOV, oh my god, I have to scroll up anyways. VOV is nothing but 0.9, so it's 0.9 times 5 times 10 to the negative 3, which is nothing but 2 times 10 to the negative 3. Right, so it's just 2 milliamps per volt. And R0 is nothing but VA over I, or 1 over lambda I, we've been through this, which is nothing but 40 over I, and I is 0.4 milliamps, so it's nothing but 100 kiloohms is R0. That's B. C. If the terminal Z is grounded, terminal X is connected to a signal source with a resistance of 1 megohm, and terminal Y is connected to a load resistance of 10 kiloohms, find the voltage gain from signal source to load. From signal source to load. Okay, so we'll proceed very cautiously, and the first thing I'm going to do is We drew a T model for the last one, so let's switch over to pi model now. We have the drain, the gate, the source, GST, GSD. This is nothing but a GMVGS. S is, okay, what do you say? Terminal Z is grounded. So first steps first, I understand that this does not exist, right? This is nothing but 0. And this does not exist. This is nothing but 0. Why? Because I said so. No, really, because all DC sources go to 0. These do not exist. This is Z. These do not exist. This is Y. Why? Because they become short circuits. And this does not exist. This is X. So given this new format, and I'm told that Z is grounded, that means that, you know, I have really current's gonna go like this, right? If I have something that's grounded, current's just gonna choose to go to the ground, right? It's not gonna follow RS, so this is like nothing. Therefore, S entirely is grounded. And I'm done with this half of the picture. And the other half says that terminal X is connected to a signal source with resistance of 1 mega ohm. So the G has two things, really. The G has RG, and it has a 1 mega ohm resistor. Really, honestly, when we see this, it's kind of like it's telling us to ignore it, right? This is kind of like an open circuit, because like 1 mega ohm resistor, no current is gonna flow through the 1 mega ohm resistor, right? It's 1 million ohms, right? Who's gonna do that? So it's kind of like an open circuit, but I don't know why they made us do this. Let's just, you know, continue. And terminal Y is connected to a load resistance of 10 kilo ohms. Okay, this is more reasonable. So terminal Y is connected to 10 kilo ohms, and Y already had RD. Now, find the voltage gain from signal source to load. So what is AV? From signal source to load. So they want to, so I'm gonna have to find VO over VI, and GV is equal to VO over Vseg, which is equal to VO over VI times VI over Vseg. Right? But there's no Vseg here. So I think I can just get away with writing AV, and that would still be correct. Should be correct. What does it say? So it's connected to a signal source with a resistance of 1 mega ohm. So there is Vseg, right? Whenever it says Vseg, there should be Vseg. So this was wrong, actually. Vseg. And 1 mega ohm. Okay. So anytime there is a Vseg or anything to do with a Vseg, you are required to find the voltage output with respect to the voltage input, then the voltage input with respect to the voltage sig, and then multiply them together to get VO over Vseg. So it's always in the order of 1, 2, 3. And 3 is your final answer, obviously, right? Now, to begin, this is my VI, VI, and my voltage output is with respect to load, right? So how do we proceed in this case? VO over VI times VI over Vseg. This is a little bit complicated, so brain loading. Let's see. What is my voltage output and what is my voltage input in this case? in this case, my voltage output would be, well, I think it's fair to say that my voltage output in this case, given that my S is 0, if I was to just look at this in another way, S is 0 means that this is, right? And so my S is 0, and so my voltage output is VDS, so AV is equal to VDS, and my voltage input is with respect to G, so by VGS, because S is 0 in this case, right? And VDS is this thing, the voltage in respect here. So VDS is nothing but GM VGS, so the current flowing multiplied by RP, where RP is 10 kilo ohms times RD, where RD is 12.5k, I believe so. RD we found to be 12.5k, right? So 12.5k over 10 plus 12.5k, and that should give me 5.56 kilo ohms. And so, or P, right? I'm basically combining this into one resistor, one parallel resistor, and I'm multiplying the current by that resistor to get the voltage at VD with respect to VS. That's kind of the game plan here. And remember, I have to reverse the polarity because I'm looking at the current in the opposite, the current flows here, I'm looking at the current in the opposite direction, such that I have minus GM VGS times 5.56 kilo ohms, and GM I have found above to be 2 times 10 to the negative 3, and this is VDS. And AV is equal to VDS with respect to VN, which is VGS, which means I can just get away with saying 2 times 5.56, which means it's going to be about 11, or yeah, 11, I'd say. Let's see, the math says minus 11.11. So this is my VO over VI. I finished step 1 successfully. What is step 2? VI over VSig. What is VI over VSig in this case? Well, what is VI? VI, as we agreed, is nothing but VG with respect to S, and VSig is VSig. You know, it just is VSig. And VGS is going to be what? What is VGS with respect to VSig? What would that even look like? So what is the voltage at this? Well, suppose I can do nodal here, would be a fair statement. So VGS, let's see, VGS minus VSig over 1 mega ohm, so the current flowing in this direction, plus VGS minus 0 over RG, so the current flowing in this direction, is equal to 0, because that's it, and RG is nothing but 10 mega ohms. So if I multiply everything by the mega ohms, then it's VGS minus VSig plus VGS over 10 equals 0, implying that VGS 1 plus 1 over 10 is equal to VSig, such that VGS is equal to VSig 10 over 10, so 11, so 10 over 10 plus 1 over 10 is 11 over 10, which I can say is 10 VSig over 11, and so VGS over VSig is equal to 10 over 11, right? And that's how I found my step 2. And finally, step 3 is VO over V sig, which is equal to VO over VI times VI over V sig, which is equal to minus 11.11 multiplied by 10 over 11. Right, so VI over V sig multiplied by VO over VI. So let's just make sure this is clear. VO over VI and VI over V sig. And that should give us something around minus 10. Yeah, it's about negative 10.1, which is absolutely correct. Okay. Let's do the final part of this question. Different video, same video. Let's finish. Let's continue. Paste. That's not the intention. I need to be better prepared. In any case, if the terminal Y is grounded, right? So again, this is nothing but X and this is nothing but Z, and this is nothing but Y, and you're saying that the terminal Y is grounded. Find the voltage gain from X to Z, with Z being open circuited, as in like it's just open-ended, as in like it does not exist. And what is the output resistance of the source follower? Well, in this case, I can just kind of see that Y is 0, so this entire thing is just going to be the ground, such that my VI is equal to my VG, D, and my VO is equal to VSD, right? Yes. Let's see. If the terminal Y is grounded, so let's draw the pi model. Here we notice that the pi model is going to be we're find the voltage gain from X to Z, with Z open grounded. You want from X to Z. You want from G to S. You want VI over V out. No, you want V out over VI. So we're going to proceed. We'll begin with the pi model. We have RG. We have this is the G, this is the S, this is the T, this is the GM, VGS. S, we see, is connected to some RS and GM, VGS, and the drain we see is connected to just straight up the ground. And G, yeah, so I think that's pretty much it. So if the terminal Y is grounded, find the voltage gain from X to Z. Well, I just know here that my AV is, I don't really know what they're asking for, but I know that AV is equal to my V over my VI, such that my AV is equal to VSD with respect to VGD, right? Let's continue. VSD is, D is nothing but the ground, so it's just VS, and VS is GM VGS RS, so I have VS equals GM VGS RS. VS is equal to GM VG minus VS times RS, such that VS is equal to GM VG RS minus GM RS VS. Bring this to one side, I get VS 1 plus GM RS is equal to GM VG RS over 1 plus GM RS is equal to VS. Right? D is 0, and I'm trying to find AV, so it's with respect to VG, so dVS, so AV is equal to dVS by dVG, or if this helps you think about it, which is going to be nothing but GM RS over 1 plus GM RS. I know what GM is. I know what GM is from here. I know what RS is from here. I plug in my values. I do the math. I get 0.95, which is not an unreasonable ask. You know, it's not completely, entirely unreasonable to ask someone to do this. Now, what is the output resistance? Now, this is a complicated, this entire question is complicated, to be honest with you. But life is complicated, so anyways, what is oral? Well, to find oral, we say what is V out. In this case, it is understood that V out is S to D, so VSD. So VSD. This means that I go from S to D, right? So I'm going to draw a line from S to D. This being S, this being D, and I'm going to connect them together with a V test. 1 volt. Agreed? 1 volt is all I'm going to connect them, test them together with. And I'm going to try to find the current that comes outside that 1 volt. So I do a 1 volt test source between them. My goal is to find the current that goes out of this. So to make life simple, let's just do nodal at S, such that Vs over Rs, so the current flowing in this direction, and we have the GM VGS is equal to GM VGS. What if I did it the other way, just to make life simpler? Such that I have minus plus 1 volt, and the current was flowing in this direction. So I had 2 currents entering and 1 current leaving, so it would equal to GM VGS plus I test. Right? And if that was the case, then what would be the answer? Well, I know that Vs over Rs is equal to GM VGS, and I know that I'm trying to isolate for I test, such that I test is equal to Vs over Rs plus GM VG minus Vs. Right? Is there any current flowing here so far? The answer is no. So I can say that VG equals 0 because there is no current flowing through it. So I test is equal to Vs over Rs minus Vs GM. Vs is equal to 1 volt, correct? Why is Vs 1 volt? 1 volt, right? This node is 1 volt, implying that this entire node is 1 volt, implying that Vs is 1 volt, such that I is equal to 1 over Rs minus GM. And R out is equal to V test over I. implying that R out is equal to RS minus GM. And so this means that if I was to multiply everything by RS, I'd get R out is equal to RS over 1 minus GM RS, and that would be right. So my error was that I test is equal to GM VGS is equal to VS over RS, which is here. And then I had to subtract this side, which I did not do, unfortunately. Minus GM minus VS, which should be negative is a plus. VS RS, VS GM, which should be plus GM, which should be plus GM, which should be plus GM RS. And therefore RO is equal to RS over 1 plus GM RS, as matches the final solution. And that was problem 7.121. Okay, so 7.123, part A. We are given that V of V is equal to 0.2 volts. This simply means that VGS minus VT, where VT is equal to 0.6 volts, is equal to 0.2, such that VGS is equal to 0.8 volts. So V of V is equal to 0.2, VGS is equal to 0.8, VT is equal to 0.6, VS is equal to 0, therefore VG is equal to 0.8. So these are just given values. Now, what must the DC voltage at the drain be? So what is VD equal to? Well, I get that here my current, right, it's flowing this way. And it has to be ID. Right? Has to be. So let's try to solve it that way. I understand that to get VD, this is VD. I will say VD, let me do normal here. So VD minus VG over R2 is equal to what? VD minus VD over RZ. Let's see. No, you know what? Let me not do this. I will do nodal at this point here. And since I'm doing the large signal analysis, this becomes 0. So this is VG. So I'm saying VG minus 0 over R1, that is the current flowing this way, is equal to the current coming in this way, which is VD minus VG over R2. And I'm trying to solve for VD such that VD is equal to R2 VG over R1 plus VG. R2 is given to me as 2 mega ohms, R1 is 0.5 kilo ohms, and VG is 0.8 plus 0.8 is equal to VT. 2 over 0.5 is just 4 times 0.8, 16, 24, 32 plus 0.8 is equal to VT. Therefore VT is equal to 4 volts. Now calculate the DC drain current ID, taking into account VA. So half Kn V of V squared times 1 plus VDS over VA. Now, we did not learn this, but I would take it this is to be memorized, simply because it just, just is. So, ID is equal to 1/2, and Kn is 5 times 10 to the negative 3, and VOV is VGS, so it's given to be 0.2 squared times 1 plus VDS. VD is nothing but 4, and VA is 60, and so ID is equal to 0.106 milliamps. Now, what value must the drain resistance RD have? So, what value does RD have? I take it VDD minus VD over RD should equal to ID, would be my train of thought. But to be certain, let us do a nodal at VD. Right? So here I did nodal at VG. Let us do a nodal at VD. Such that VDD minus VD over RD for the current going in is equal to the current leaving, which makes it equal to VD minus VG over R2 plus ID. So in essence, I'm saying that the current entering this node is equal to the current leaving this node, correct? Where ID is nothing but 0.106, where D is 4 volts, where G is 0.8, VDD is 10, RD is, I'm looking for RD, and R2 is 2 megaohms. So 6 over RD is equal to 3.2 over 2 megaohms plus 0.106, right? And so really RD is equal to 6 divided by 1.076 times 10 to the negative 4, which makes it equal to 55.7 K ohms. Part B, GM, really this is just monkey Kn VOV, which is equal to, we said that Kn is 5 milliamps, VOV is 0.2, so 5 times 0.2 times 10 to the negative 3, which is equal to 1 times 10 to the negative 3. R naught is equal to 1 over VA, nope, sorry, that's RM. Naught is equal to VA over I, or is equal to 1 over lambda I, and VA I'm told is 60, and I is 0.106, so naught is 566.037 ohms, and this also makes sense. Now, using the small signal equivalent circuit of the amplifier, show that the voltage gain is given by, and then we get this very complicated equation. So I guess the first step is to use the small signal model in order to be able to find the R naught, right? And so we begin. Let's use a small signal model of this equation. Copy. And so I see that this is nothing but V sig, and we have R1, this is my G, this is my S, this is my D, this is my GM VGS, S, so drain to source, and this is my volt. So I see that my source is just grounded, and I see that my drain is connected to an RD that is connected to ground, and I see that I have a resistor between my drain and ground. So let's do this G, and this resistor is R2. Right, so using the small signal model, show that VO over V seg, you want VO over V seg. If I'm looking for V out over V seg, my first step will be to say that my V out is equal to VDS. My V in is equal to VGS. So VDS, right, is nothing but VD, since S is equal to 0. So if I was to do nodal at D, right, so VD minus VG over R2 plus GM VGS plus VD minus 0 over RD is equal to 0. And so VG here, or VS here, is 0. So I could say that VD and VG here is this spot, right? So that VD minus VG over R2 plus GM VG plus VD over RD is equal to 0. And that's pretty agreeable. The is equal to VTS is equal to VT. If I wanted to isolate for VT, but there's no point in doing that right now. Let's do nodal at G. VG minus V seg over R1 plus VG minus VD over R2 is equal to 0. And so if I had to multiply both sides, I'd say VG R2 minus V seg R2 plus VG R1 minus VD R1 is equal to 0, such that VG R2 plus R1 is equal to VD R1 plus V seg R2, implying that VG is equal to VD R1 plus V seg R2 over R1 plus R2. And then I could say that now that I have VG, I could write VG in terms of V out over V seg, right? So I could write VG in terms of VD R1, V seg R2, R1 plus R2, such that I say that VD over R2 minus VD R1 plus V seg R2 over R1 plus R2 times R2 plus GM times VD R1 plus V seg R2 over R1 plus R2 plus VD over RD is equal to 0. Right? And then it becomes trivial to show that VO which is really just VD over V sig, right, is equal to that expression that they wanted. So this is just math. It's 4 pages of math. I'm not going to do it because it's just math, pure math. And I doubt that we would be asked to do this in any electric application. But just use this to find VD over Vsig, or isolate for VD over Vsig. Everything else is given, so we do a lot of math and we get the final answer. And that was 7.123. Hello, this is Boba here. So we're going to solve this question. The first thing we're going to do is we're going to read, because this is my second take, because I did not read it correctly. Notice that it says RS or D common source. Okay. So let's just get a head start. We're going to draw RD, VT, VS, VG, RS. Common source means that VI is equal to VGS, Vout is equal to VGS, and this is VG. Now, I need to find a V equals what? Now, if you have the formula memorized, then, that's good on you. You can just skip the following. I don't, so I'm going to have to derive it from first principles, which kind of sucks. But anyways, to get a V, I'm going to have to transform this. I'm going to use the pi model. I use G, I use S, I use D, G, S, D. GM, VGS. The source is connected to an RS, which is connected to the ground, and the D is connected to an RD, which is connected to the ground. This is my VD, this is my VS. And this is my VGA. Okay, so my VI is VGS and my Vout is equal to VDS. So step 1 is find VDS, which is equal to VD minus VS. Right? Let's see. Do I need to find this? Well, technically speaking, since it's a common source, I could get away with saying that VDS is equal to, that AV is equal to VD with respect to VG. Well, I guess in any case, my first step is going to be to find VD. What is VD? So VD is equal to minus GM VGS or D, none of which simplify to 0. VD is equal to minus GM VG or D minus or plus GM VS or D. Okay? And VS is equal to GM VGS or S, which is equal to GM VG minus VS or S, which is equal to GM VG or S plus VS GM or S. So VS is equal to GM VG or S over 1 plus GM or S. That's what VS is, right? And so here I can say that VD is equal to minus GM or D VG plus VS. So it's VG minus GM VG RS over 1 plus GM RS, which is equal to minus GM RT VG 1 minus GM RS over 1 plus GM RS, and that could equal to minus GM RT VG 1 plus GM RS over 1 plus GM RS minus GM RS over 1 plus GM RS. This is just 1, and so I simplify this to minus GM RT VG 1 over 1 plus GM RS. That's my VD. And my VD is my output, and my VI is nothing but my VG, and therefore VD with respect to VG is equal to minus GM or D 1 over 1 plus GM RS, and that's my formula. Now it's easy. After this it becomes plug and chug. Given this formula, I say when the overall gain within RS is equal to 200 ohms is equal to minus 10. So minus 10 is equal to minus GM or D 1 over 1 plus GM times 200. Right? Now when RS is shorted as in RS is equal to 0, there is no resistance, the circuit operation, the gain doubles. So minus 20 is equal to minus GM or D times 1 over 1 plus 0, which is nothing. So 20 is equal to GM or D, which means that now I have two unknowns, two equations, plug and chug. Let's say GM is equal to, what do I want to say GM is equal to? Let's say GM is equal to 20 over RD minus, so 10 is equal to 20 over RD times RD 1 over 1 plus 200 GM. Cancel, 10 over 20 is 1 over 2 is equal to 1 over 1 plus 200 GM, so 2 is equal to 200 GM plus 1, so 1 is equal to 200 GM, so GM is equal to 1 over 200, which is equal to 0.005. So GM is equal to 0.005. RD is equal to 20 over 0.005, which is equal to 4 kilo ohms. And having said that, I have finished the first part of the question. Let's move on to the second part of the question. What value of RS is needed to obtain an overall voltage gain of, so AV is equal to minus GM RD 1 over 1 plus GM RS. What value of RS is needed to obtain minus 16 is equal to minus 0.005 times 4 times 10 to the 3 1 over 1 plus 0.005 times RD. I have one unknown, I solve for it, minus, so it's going to be 16 over 1, 2, 3. 5 times 4 is 20 is equal to, so this is 4 over 5, or 0.8 is equal to 1 over 1 plus 0.005 RD. In other words, 1 plus 0.005 RD is equal to 1 over 0.8 minus 1 all over 1 over 0.005 is equal to RD, and therefore RS is equal to 50. And does this make sense? I mean, yeah, this is a number slightly larger than 1. Right, this is like something slightly larger than 1. I divide it by 0.005. I expect a big number, which is 50 in this case. And I'm done with this question. So this was a Nice question. It was kind of simple. And the trick really was in understanding what VI and V output was. If you had done VGS and VDS, I mean, you could have solved it still. However, it's much easier to say VG and VD. And really the trick is once you get your V output, right, it should just be in terms of one thing, and that other thing should be something that you can eliminate, something that you can cancel out. And we're done with this question. One more to go. Okay, so our final question is 7.103. So this figure shows a variation of the feedback bias circuit of 7.52. In any case, using a 3-fold supply with an NMOS transistor for which VT, so VT is equal to 0.8 volts, Kn is equal to 4 times 10 to the negative 3, lambda is equal to 0. To provide a design that biases the transistor, ID is equal to 0.5 amps. So ID is equal to 1/2 Kn VV squared, and ID is equal to 0.5 milliamps with a VDS large enough to allow saturation. So VDS has to be greater than VOV. Implying that VDS has to be greater than VGS minus VT. Right. For a 1-volt negative signal swing at the drain. So really, it's VDS minus 1 has to be greater than VOV. So VDS has to be greater than VOV plus 1. Right? Use 13 mega ohms as the largest resistor in the feedback bias network. Okay, so where do I proceed from here? Well, I understand that S is equal to 0. So anything that has to do with S I can just remove. So VD is greater than VOV plus 1, and VOV is equal to VGS minus VT, which is equal to VG minus VT. That's my value for VOV, right? Now just looking at this circuit, what is VOV? What can I say about VOV? Again, VOV is equal to VG minus VT. Okay, so what can I say about VG? This is VG. So VG minus 0 over RG2 plus if I just did nodal here, would that work out to me? No, probably would not. Another way for me to do this would be to understand that VG VG is nothing but the voltage dropped across RG2. That part is understandable, right? So it's VDD minus 0, right? So I want the current, basically what I'm saying is I want the current here, I, times RG2. And that current is VDD minus 0 over RG plus RG1 plus RG2. Given that the current is going to flow in this direction. And would that be correct? To assume this, I suppose, can current go in this direction? Well, yes, but actually, does current flow from drain to source? It absolutely does. Does it flow from drain to gate? In this case, yes, it does as well. So we're just going to assume that it does, and we will go from there. I mean, we can easily prove it if we use the T model, where this is your drain, and this is your gate, and this is your 1 over RM, and this is your GM VGS, and this is your 1 over GM, and we can show that the current entering here is countered by sort of the voltage here, and so this happens. But in any case, just trust me on this. So VG is equal to VDD over RG plus RG1 plus RG2 multiplied by RG2, which would be equal to exactly that, right? So VOV is equal to VDD over RG plus RG1 plus RG2 times RG2 minus VT or minus 0.8. Okay, that part's understood. And I know from this equation that ID, which is 0.5 milliamps, is equal to 1/2 Kn, which is 4 milliamps. So I can just cancel this with this. 1/2 is 2 times VOV squared, such that VOV squared is equal to 0.5 over 2 or 1 over 4, such that VOV is equal to 1 over 2. Right? So now I can say that 0.5 is equal to VDT minus RG2 over RD plus RG1 plus RG2. We know that VDD is, wow, apparently VDD is not given. Okay, that's okay. We take those. In any case, minus 0.8, 1.3 is equal to VDD minus RG2 over RG plus RG1 plus RG2. Right. We leave this, we continue to the next part, which is to say, what is VD? VD is going to be it says 3-volt supply, right? So right now I have one equation, 3 unknowns, right? The second equation should be to find something that relates to VD, and VD is equal to 3 minus 0.5, rather VDD minus ID RD, which is equal to 3 minus 0.5 times RD. That's equal to VD. And so, with the understanding that VD has to be greater than VOV plus 1, one can say that VD is 3 minus 0.5 RT. This has to be greater than what does that have to be greater than? 0.5 milliamps, first of all, times RD has to be greater than VOV, which is equal to 0.5 plus 1. Right? This implies that minus 0.5 milliamps RD is going to be greater than 1.5 minus 3, or minus 1.5. So RD is less than 1.5 over 0.5 times 10 to the 3, apparently. And so 1.5 over 0.5 is just 3. So RD has to be less than or equal to 3 kilo ohms. So So I'm just going to say RG is equal to 3 kilo ohms. Why is that? Because it asks us to use 13 mega ohms as the largest resistor in your feedback bias network. Okay. So now I know that 1.3 is equal to 3 minus RG2 over RD plus RG1 plus RG2. This is an absolute mistake, by the way. This is VDD times RG2, and this is VDD times RG2. Right? So 1.3 divided by 3 is equal to RG2 over 3 kilo ohms plus RG1 plus RG2, right? And one of them has to be 13 mega ohms. So now it's just like an ansatz. I guess that RG1 is equal to 13 mega ohms. I cheated a little bit because I want to do the extra work. If you had done it the other way, you would get something wrong, and therefore you would know that you have to, you know what? Yeah, no, I'm not gonna do the extra work, but if you did it the other way, the math would correct you, and you just have to take the other guess. But let's take the guess. Let's assume that RG2 is equal to 13 times 10 to the 6. So 1.3 over 3 is equal to 13 times 10 to the 6 over 3 kilo ohms plus RG1 plus 13 times 10 to the 6. And therefore 1.3 over 3, which is 0.433, divided by 13 times 10 to the 6 is equal to 1 over 3 times 10 to the 6 plus 13 times 10 to the 6 plus x, or RG1, and that gives us RG1 is equal to 17 mega ohms. And we say that 16 use 13 mega ohms as your largest resistor value, right? And so this tells us that we are actually wrong. I'm just sifting through, trying to find an actual proper calculator to use. But anyways, I ended up doing what I did not want to do. This is wrong. So let RG1 equals 13 times 10 to the 6 mega ohms. 13 times 6 ohms, right? Such that 1.3 over 3 is equal to RG2 over 3 kilo ohms plus 13 times 10 to the 6 plus RG2. And with a bit of math, we get 1.3 divided by 3 is equal to x over 3 times 10 to the 3 plus 13 times 10 to the 6 plus x. And we get RG2 is equal to 9943470. Whoa. 3, 1, 2, 3. Which is equal to 9.94347 times 10 to the 6, which is equal to 9.9435 mega ohms, which is good because this is not the largest. So I ended up actually doing what I didn't want to do, but that's all good. It's all good. I'm not. If we had taken the ansatz of RG2 is equal to this, we would find that RG1 is equal to 17 mega ohms, which is greater than max. So this is wrong. I'd repeat with a different guess of RG1, which I did, and leads me to the actual correct value of 9.9435 mega ohms, and that's the correct value. And this was problem set 7, and I'm out.